Welcome. My name is Maura McGinty-Kloss. I'm Director of Programs and Communications for the Natural Areas Association, and thank you for joining us today. Today's webinar is the Map of Biodiversity Importance, Enhancing Local Conservation Strategies, and it will be presented by NatureServe. We'd like to thank the Department of Interior, Bureau of Land Management for sponsoring this webinar today and helping us to keep this important information in front of you. For those of you who don't know, the Natural Areas Association is a national nonprofit organization that serves those who steward the land and protect biodiversity. Our mission is to get quality science and best practices into the hands of those who can make an impact on the ground by sharing applied science, practical solutions, and new knowledge through both in-person and digital opportunities. NAA's digital content includes symposia, webinars, videos, and we release new content on our YouTube channel at 11 a.m. every Friday. We also publish the Natural Areas Journal quarterly and distribute the Natural Areas News twice a month, which comes free to your inbox. If you've registered for this webinar, even if it's your first time, you will now start receiving Natural Areas News. So NAA is available wherever you are located, wherever you are in your practice, wherever you are in your career, and most importantly, whenever you have time. The Natural Areas Conference is right around the corner, October 7 to 10 in Manhattan, Kansas. We're so excited to have so many people registered, practitioners registered for this conference. Registration is open through Monday. So for online registration, late registration is available after that. But if you would like to join us, it's not too late. For more information about the conference, future webinars, and other programs of the NAA, please feel free to use this QR code or just go to our website, naturalareas.org. So before I introduce today's presenters, I'd like to go over a few housekeeping items. If you wish to add captions during this program, you may do so by selecting Show Captions, which is located on your Zoom navigation bar. We also encourage you to participate in today's session by posting comments or shared resources or just chat about the program in our chat feature. If you have a question, however, please post that in Q&A because it allows us to keep questions separate so that we can go through them as opposed to them getting lost in some of the conversations that happen on chat. And then we will address all the questions in Q&A, as many as we can, after the presentation. And if we run a little over, we still will ask all the questions. This is being recorded, and that way, even if you had to drop off a little early and your question wasn't asked, it will get asked before we end, and you can go back and check that in the recording. Everyone who's registered today will receive a copy of the recording. We will email it to you, as well as any resources within about a week of the program. And now I'm going to introduce our presenters today. So Chris Tracey, who is the Director of Spatial Analysis, NatureServe, focuses on developing and delivering data to inform biodiversity conservation. Before joining NatureServe in 2022, he was an ecologist and managed conservation planning activities for the Pennsylvania Natural Heritage Program. And unfortunately, Chris has been under the weather, and it is impacting his ability to speak clearly and do presentations. So he will be with us today. He'll be available on chat. He may be answering some questions, but we are very fortunate to have his colleague today, Regan Smythe, who has joined us, and she will be doing the presentation. Regan Smythe, Vice President for Conservation Science, is at NatureServe, where she oversees the development and management and provision of core data resources on North American species and ecosystems. By collaborating closely with NatureServe Network of data providers, technology partners, federal land managers, corporate data consumers, and other conservation actors, Regan works to ensure the decisions impacting North American species and ecosystems are informed by high-quality data and science. Regan has a master's degree in ecosystem conservation management from Duke University and a bachelor's degree in biology and environmental science, also from Duke University. So now, Regan, I'm going to invite you to take over, and we can start the program.
Sure. Thank you very much. All right. Okay, well, thank you so much for having us today. And I know Chris is very sorry that he can't be the one giving this presentation. He deserves a lot of the credit for this work, but I am happy to be able to stand in his place. Today, we are really excited to be sharing an update to the Map of Biodiversity Importance, which is one of NatureServe's signature data products that synthesizes all this great information that our network of local partners is collecting. We'll talk a lot more about what's in the map, but that's the general plan for today, to both share that new product, talk a little bit about how it was created, and then how it can bridge to additional resources that can help planning at more local levels. I'll start by giving a little bit of a background on NatureServe, providing the overview of the Map of Biodiversity Importance so folks can really understand what those data layers represent. Talking a bit about what's changed in 2024. It's been 5 years since we originally released this product, so there's lots to talk about there. And then speak to how you can access these resources and how they're being applied on the ground, often in combination with a lot of the great data that NatureServe's network of partners provides in the States. Before we dive in, though, we did want to pull up a little bit of a poll and learn a little bit more about the people on the call so we can help direct the conversation. So, Maura, can you pop that up? All right, so just asking a couple of questions. One, how familiar are you with NatureServe? The second is how familiar are you with your state natural heritage program or the NatureServe Network program in your state? Sometimes they go by different names. And also what region of the country you're coming from. So if you could just take a moment to fill that out, we'll keep going. Okay, so here are our results. I'm just taking a look. So there's a range with how familiar people are with NatureServe. People are a little bit more familiar with their local programs, which is great, although some people aren't familiar at all. And then we have some pretty good geographic representation on the call. All right, well, that's helpful to me as I keep talking. So I do want to talk a little bit about who NatureServe is and why we're the ones in front of you today. There's many on the phone who have worked with us for a long time, but there's also those of you who are really just learning about NatureServe for the first time. This year marks our 50th anniversary as an organization that's guiding biodiversity conservation and stewardship within North America, really focusing on the power of science, data, and technology to inform conservation decision making. We are a biodiversity informatics network. I'll talk a little bit more about that on the next slide, but our mission is really to provide this foundational knowledge that helps people make good decisions in service of conservation. We do that as the hub of a network. So 50 years ago, NatureServe's visionary founder, Dr. Robert Jenkins, set out to build what really was the world's first biodiversity information network. Today, we have more than 60 network partners throughout the US and Canada. These are programs that are staffed with local experts that are collecting information on the ground about what's going on in terms of species and ecosystems in the jurisdictions in which they work. Often in the US, those are called natural heritage programs, but they go by a variety of names, and we consider them NatureServe member programs or network programs. By design, the NatureServe network tracks all species, vertebrates and invertebrates, plants and fungi, really trying to represent the full diversity of life within North America. We also systematically identify and classify ecosystems, and use standardized methods to assess the conservation status of those species and ecosystems. Altogether, our databases hold information on more than 100,000 species and ecosystems with more than 1.3 million mapped locations. NatureServe's at the center of this, but we really, as I said, do this in collaboration with these member programs across the states and provinces in Canada. One way to measure our impact is how our information is used. Our data contribute to understanding what's happening in the natural world, as represented in some of the media hits that are shown on the screen. We're also a trusted source for federal agencies, private industry, those who really need to know what's going on the ground, in terms of biodiversity. And a huge part of what we do is support that network of state natural heritage programs and through that other local conservation actors by providing really this consistent understanding of North American species and ecosystems. Today, I'm going to be focusing on what's really one of our signature information products, the Map of Biodiversity Importance. This map, it's actually a series of maps, but we first released it back in 2020, was published in Ecological Applications. The headline up here is from an article in the New York Times that came out upon its release. And the purpose of this map was really to synthesize all this information that's being collected and shared with NatureServe across the country. What you're looking at, the dark pinks on this map are showing those places where there are concentrations of range-limited at-risk species in the US. The places we really need to be paying attention to if we want to prevent species extinctions and keep this vibrant life that we all care about going strong in our country. Recently, we re-released a new version of this for 2024, and that's really why we were invited to come talk today and what we want to focus on. In the next few slides, I'll walk you through how that map was developed, what has changed with this update, and also go through some examples of how these data can be applied to direct conservation locally and other data resources that can help you do that well. So as I said, the Map of Biodiversity Importance is really a synthesis of all this great data coming from the NatureServe Network. It uses data on both location, where species occur, but also conservation status, what's at risk. By synthesizing all that information, we get to a series of data layers that depict conservation priorities for at-risk species. And those priorities consider conservation status, what's at risk, range size, so how many opportunities for protection are there, and protection status. So is this a species that's already protected? And I'll go in a lot more detail about how we do that. The Map of Biodiversity Importance was developed with a lot of support. Those programs in the NatureServe Network were instrumental in its creation. As Maura shared in the introduction, Chris Tracey used to work at the Pennsylvania Natural Heritage Program. He was instrumental in the first version of the map and has been more than instrumental in the second version since he's become an employee at NatureServe. It really is a group expert or a group endeavor that pulls in the expertise of that full network of partners. We also were supported financially and with tech assistance by Esri and the Nature Conservancy, as well as Microsoft's AI for Earth Foundation. And this new update is largely possible because of support from the Hewlett Foundation. So I said this is a synthesis of our data. Let me talk a little bit about what that means and how the NatureServe Network really works. So NatureServe as the hub of this network really provides the core technology and consistent methodologies so that information from Arizona and California and New York and West Virginia can all flow together and be used together. And we do that with a software program we call Biotics. There's state instances of that. There's a central version of that. that system allows information being collected by our partners out in the states to kind of roll up and be able to be used in these regional and national analyses. So data is coming in from our programs in the field. We're using this common infrastructure to exchange that information. And then on the other side of that is a whole bunch of synthesis products. So NatureServe Explorer provides species profiles. So it's an online website where you can kind of see what the NatureServe Network data tells you about a species. Explorer Pro is sort of a map version of that. Our conservation status assessments, the way we know what's at risk, uses all that information. And important for today's discussion, the Map of Biodiversity Importance really brings that all together, brings the information on what's at risk, where it is, and integrates it into, a single data layer that can be used for conservation applications. It's a lot of stuff coming together. When we say NatureServe manages a lot of information, often we break that down to information relating to these three questions. What is it? What's that common taxonomic background that lets us all be talking about the same things? Where is it? Where do those elements of biodiversity occur across our network? And that's where those state programs really come into play. And then this question of how is it doing? So how do we even know what is at risk? What should we be paying attention to? A big part of the role we fill in the conservation landscape is answering these questions. And the answers to those questions all, as I said on the last slide, roll into the Map of Biodiversity Importance, or MoBI. So conservation status assessments, that's how we quantify what's at risk. And I did want to take a moment to talk about that process. So one of the really core things to know is just, what should we really be paying attention to? And that can be really difficult to know. NatureServe has developed a standardized methodology that really serves as a de facto national standard for quantifying extinction risk for species. And we have a similar system for ecosystems. But this considers things like rarity and threats and trends for each species. We assign, based on an assessment of those rank factors, we assign a conservation status from critically imperiled to secure. And a similar process is used by our state partners to assign subnational or state-specific conservation ranks. Really recognizing that there may be a species that's globally, it's secure, but it's of conservation interest within the states. Nationally, when you look at these assessments, about 1/3 of all plants and animals are considered at risk of extinction. That is, they're vulnerable or imperiled on our scale. G1 here, it might be a little hard to see on the slide, but that's the red is species that are globally or critically imperiled globally. Orange is imperiled, yellow is vulnerable. You're seeing here a synthesis of information for all plants in our database. So about 1/3 of plants nationally are considered vulnerable and above. We use this information in the Map of Biodiversity Importance to figure out what species to include. So this is what the map includes. It includes anything in the lower 48 states that has been assessed as being globally imperiled or globally critically imperiled in the taxonomic groups that are listed. So all vertebrates, certain groups of aquatic invertebrates, mussels and crayfish, certain groups of pollinating insects, butterflies and skippers, and bumblebees and solitary bees, as well as all vascular plants. We really wanted the Map of Biodiversity Importance to represent the full spectrum of biodiversity in this country. There's a lot of effort or interest in bird conservation, and that's really important. But if you look at those graphs of what's most at risk, it's the aquatic invertebrates that we're really losing. It's things like pollinators that we need to be paying attention to. And so we wanted to ensure that this product really represented that full spectrum of the life that supports us. In addition to those things that are imperiled or globally imperiled, we also included any species that had been listed as threatened and endangered under the Endangered Species Act. as long as they were listed at the full species level. So we didn't include things that were just populations of listed species, but if the species was listed, even if it was not imperiled by our ranking system, we included those species as well. So that's what goes into the map. I said that NatureServe, one of the big questions we answer is where are things? And we do that with this unparalleled data set of element occurrence data that our network has been collecting for 50 years. So in every state, there are state programs that are often out doing biological surveys. They're collating information from other sources, and they're delineating areas of conservation significance for all the species they choose to track in the state, which is often those things that are globally imperiled, but sometimes beyond that as well, things of state conservation interest. This map shows a compilation of those data sets. There's nothing else like this out there, and it's extremely rich and powerful. The thing that the element occurrence data doesn't tell us, though, is what's going on in places we haven't looked. So when we set out to make the map of biodiversity importance, we asked, how do we fill in those blank spaces? How do we know comprehensively what's going on for these at-risk species, even if there hasn't been a survey there in that area in 40 years? Because we all know there's not really the resources for biodiversity inventory that are needed. We answered that question by building predictive models. So for the over 2,000 species that met our criteria for inclusion, we took that element occurrence data from our network. We intersected it with a series of environmental predictor data sets, things like soils and climate and landform. And then we did a whole bunch of fancy math, right? We used AI, machine learning, to build predictive models of where those species are likely to be found, where you have conditions on the ground that match those places where species have been observed. NatureServe has especially, we did this 5 years ago with the original map of biodiversity importance. In the 5 years since, we really have been honing those methods for creating these predictive maps. One of the really powerful things that we've built into this is a process for review. So we have all these great knowledgeable species experts in our network. We can create these, AI generated maps, but then we can put them in front of the people who know the species and get them reviewed. Not all the models that are included in this version of the map have been reviewed, but many have by our network of experts. In many cases, we can also, feed those models to the people who are doing inventory and use them to collect new data and make models better over time. The great thing about this version of the Map of Biodiversity Importance is it is that second iteration. We've refined our modeling processes. Our reviewers are saying that our models today, exceed often our better predictions than what we had 5 years ago. And we're continuing as new data comes in from our network to hone those models. Okay, so we had all this data, we did all this fancy math, we produced these maps of where you have a high probability that a certain at-risk species may be found. Now we want to put that all together, right? We want one single map or at least a series of maps that tell us, based on all this information for individual species, where do you have areas that are important for many species or for species that are particularly at risk? That is what the Map of Biodiversity Importance does. So essentially, we stacked up each of those individual species models for those 2,500 plus species, and we created 3 different types of data layers. At the simplest, we produced layers, a map of species richness. So for every grid cell across the country, we counted the number of species with habitat predicted in that area. Pretty simple, right? There's 5 at-risk species known for or likely to occur in this location. That is great and easy to understand. It's not necessarily, though, the best layer to use when you're asking what are the most important places to protect. And that's because range size really matters. So if you have a species that's everywhere, let's say a bat, with a very wide range. The opportunities for protection are many. It's not quite as critical. Any one spot where that species is predicted is not quite as critical as, say, the 2 acres where a super rare plant is found. So we weighted each of those species by the range size. So species with smaller ranges were given a higher range size rarity score. And then we stacked that up, and that gave us a map of where do you have many species, or just a few species, but that which have very few conservation opportunities. And that's our range size rarity maps. And we'll look at all of these in a minute. And then the last set of products is what we call protection weighted range size rarity. So that's that same concept. We're still stacking up all those individual maps, weighting them by range size or kind of number of conservation opportunities, but also applying a weight based on protection status. So species that are largely unprotected, that fall outside the protected areas, real estate, are weighted heavier in that version. The graphic here is just showing you what that looks like in practice. This is from a pixel in Texas where you have golden-cheeked warblers. Those have a relatively big range size, but they're relatively unprotected. So that contributes to the score seen there. And we just add all those things up. So this is what we get to. These maps were focused here on the Western United States, but I'll have maps coming later where you can see the full extent. This is species richness. As I said, it's pretty intuitive. It's the number of those imperiled species that co-occur in any given grid cell, and the grid size cells here are 330 meters. That's sort of our basic map of biodiversity, most basic map of biodiversity importance product. Here is that summed range size rarity. And this is really what we're recommending that people use when they want to identify areas of high conservation value for at-risk species, which occur on and off protected land. This is one that's really a more interesting map. And it's showing us that, across this geography in pretty much every state, there are areas of high importance for at-risk species. This map takes it one step further. This is the protection weighted range size rarity. So the green on this map is showing protected areas that are managed for biodiversity. So things that are GAP status 1 or 2 in the US protected areas database. We use that to calculate the percent of the habitat protected for each species, and then again, weighted that and stack those layers up. So the darkest pinks here are where you have those concentrations of range limited under protected species, and really highlights the areas that are very important targets for land protection efforts. One more map here. Here we've taken that and we've just thresholded it to show those areas that score highest. We call these areas of unprotected biodiversity importance. This is kind of the highest of the high in areas for that protection weighted range size rarity metric. So those are the basic map of biodiversity importance products. Up here is that national map for range size rarity. I wanted to talk a little bit about what changed between that original map that we released in 2020 and the 2024 edition. One of the biggest changes is just what species were included. So our rules were pretty much the same for both. We included those G1 and G2 species and things listed at the full species level. But one of the big challenges that NatureServe and really the conservation community faces is that our information on those at-risk species is changing constantly. There's new understanding of taxonomy, new species are differentiated, there's new understanding of what species are at risk. So in the 5 years between when we started this project and now there were 170 species which were dropped either because we reassessed their conservation status and realized they weren't as much at risk as once thought, or they may have been, new understanding of taxonomy may have indicated that they're not actually the species they thought they were. They might have been declared a subspecies or something like that. We added about 450 species. So this is about a 20% change in the species list, which really just speaks to the challenge of maintaining good biodiversity information. One other thing that changed was the protection area, the protected areas layers. So in this version, we use PAD-US 4.0. So when we did those calculations of what's protected, some of that changed. We also added a whole group of pollinators. So one of the criteria for which species we include in the map of biodiversity importance is which species we have comprehensive data for the taxonomic group. There's some things like fungi, which we just don't have the knowledge comprehensively of what's out there and what's at risk. Because a lot of work has gone into assessing the conservation status of pollinators, we were able to add that new group of pollinators, solitary bees. So that was 41 new species on account of that. The map we just released is also 9 times more precise than the 2020 version. So in 2020, the areas of importance were mapped with pixels that were 990 meters in size. We felt comfortable with our methods to really take that down a notch and do that mapping at a finer resolution at 330 meters. And I'll show you a little bit of the difference that makes, but I think that's one of the most significant changes with this version is just that higher resolution of the data. We also, when we built this time, we built it in a way that will facilitate updates and custom aggregations. So what NatureServe would like to be able to do is keep this map synced with all the other data in our databases to do annual updates that reflect the current knowledge of what's at risk and where those species occur. The other thing that we built along with that is the ability to create custom MoBI maps. I mentioned that, NatureServe, this map includes things that are globally imperiled. Many states, have their list of things that are imperiled at the state level and would like a map of that. With the ability to do custom aggregations, we can we can work with anyone, get the list of species they're interested in and really build products like this to meet different needs. Okay, so I said that what you're looking at here is a 2020 version of the map. I mentioned that one of the things we're really excited about is that change in resolution, and I want to show you what that looks like. I'll turn it on in a sort of swipe video in a second, but before I do that, I wanted to talk a little bit about the patterns that the map revealed. When we first created the Map of Biodiversity Importance in 2020, the results were pretty interesting. So they matched, kind of common understanding of biodiversity hotspots. You can see that the California floristic province is really glowing. You can see the Southern Appalachians pop out. These areas that really have long been appreciated as biodiversity hotspots. But we also revealed some much less appreciated patterns. I think somebody in the chat in the beginning mentioned they were from the Rio Grande in southern Texas, and that area really popped out as this underappreciated biodiversity hotspot. We saw the same with the Lake Wales Ridge in Florida. The people there locally may know it's important, but it really wasn't previously popping out on kind of the global stage. A couple other places of interest that pop out in this map. The Southwest has huge concentrations of imperiled plants. The Ouachita Mountains, the Ozark Mountains are kind of these little glowing hotspots that really the Map of Biodiversity Importance helps make that case that, yeah, these are really important spots for biodiversity in our nation. The other interesting thing, though, is those aren't the only spots, right? There are dark pink areas pretty much in every state, and there is imperiled biodiversity all around us. With the 2024 update, it's pretty similar at those broad scales. It shows the same patterns, but in a few areas, we are picking up newer areas of importance, particularly where there's species that have been added to the map. But the biggest change, I think, as I said before, is it's the resolution of that data we're providing. From going from that essentially 1 kilometer to 330 meters, we're starting to be able to pick out specific geographic features that are driving the patterns. And so I'm turning on an animation here. I'll do this. I'll go back and forth a couple of times, but this is just showing the transition from that 2020 map to the 2024 map. And especially if you look, where we're zoomed in, you can see how it's, getting at those unique features, those valleys or streams, and really focusing in. Here's another picture of that. We're in northern Arizona now. I'll turn on the animation. Don't blink, this goes pretty fast. Wait, there we go. So we're pretty excited to, whoops, do that one more time. There we go. So yeah, it really is just narrowing in. This one's one of my favorites. Southern Appalachians. You can really start to see, right, all those stream networks with that rich aquatic biodiversity. So that's the product that's out there now. I'll talk a little bit more about how you can all access it. How am I doing in time? All right, so just quickly, this is a comparison of those two maps, the 2020 version and the 2024 version. The pink areas are areas that stayed consistent. This is looking at that thresholded version of the map, the areas of unprotected biodiversity importance. Areas in yellow were in the old map, not in the new map, meeting that threshold. In most cases, those are just because of the resolution in the map. In some places, it might be because a species dropped out, but for the most part, we're just narrowing in. And so that's why you see those yellow areas popping up. Lot of consistency in the pink. In 2024, those areas are kind of important. Those are those newly identified areas of importance. Most often it's because we're adding some new species, and we're seeing a lot pop up in areas that weren't glowing quite so bright in previous versions. So that can be pretty interesting depending on where you are. And as I mentioned before, the things driving these changes are those taxonomic updates, the changes in conservation rank, that improved resolution. In many cases, we actually refine the original model, so a better depiction of range. Because we're working at finer resolution, the calculations of range size rarity change a little bit, and then we have those Bs as well. Want to give one little word of warning. When you look at the 2020 products and you look at the 2024 products, for those of you who have been using the Map of Biodiversity Importance, caution you against, if an area is dropping out or being added, that doesn't necessarily mean something changed on the landscape. It really means our understanding of what's at risk has changed. And so, or just, there's artifacts of the resolutions of the map. So it is a little bit hard to, people want to take those maps and look at them together and say, oh, these areas changed. That's not necessarily what it's saying, since the methods, the resolution's a little different, and that species list is really driven not always by real change, but just change in understanding of what's at risk or what's a species. Wanted to use these three species really to illustrate that change, as well as just this challenge that NatureServe faces in keeping biodiversity data up to date in this time when, extinction rates are skyrocketing and so much is changing about the planet. Each of the species shown on the screen here was not included in the original Map of Biodiversity Importance, but is included in this newer version. And that's because 5 years ago, when we first started thinking about MoBI, we didn't even realize these species needed our attention. The salamander on the left there wasn't described to science until 2021. We made the species list for the original MoBI in 2018, so he didn't make the cut. The bumblebee and the cactus were newly identified as imperiled just in the last 5 years. So our understanding of their conservation status changed. As taxonomic understanding has evolved and appreciation of risk to pollinators has increased, as activities like collection and mining continue, these species are being brought into the spotlight. Our understanding of biodiversity is constantly changing. As I said before, the list for this version of the map was 20% different than the original. And I think this will just be my shameless plug that really, if we're to effectively respond to the biodiversity crisis, we need to invest in having good information and keeping that information current. It's a struggle for NatureServe to do that, but it's why we're here. And we feel very strongly that somebody needs to fill that role, that we need to have a consistent way to manage information on the species in our country, so the decisions we make can be based on our latest understanding. And that's one of the reasons we're so excited to be releasing these updated products. Okay, so how are these maps being used? So MoBI's been around for 5 years now, so we have been pretty heartened to see just the amount of uptake it's gotten. We have seen the Map of Biodiversity Importance used by conservation investors in prioritization. So the Hewlett or the Pew Foundation are asking, where should we be focusing our investments? What watersheds should we be working in for river prioritizations? These maps have been used to inform those kind of decisions. The MoBI maps have been used to identify high conservation value forests in the Southeast in ways that are being used to support sustainable forestry, identifying those places that really are so valuable they shouldn't be being harvested. They're being used in numerous ways in kind of regional scale conservation planning tools. So one example of that is the Forest Service's Climate Risk Viewer, which really synthesizes a lot of national layers to help folks understand how best to manage forests in this time of climate risk. The MoBI maps have gone into numerous 30 by 30 planning efforts. Folks like Defenders of Wildlife have taken the maps and used them to kind of identify, if you want to save 30% of the planet by 2030, which 30% should we be focused on? They can really help on big kind of national, regional questions like that. We've been working with a number of partners to explore how these maps can inform corporate sustainability reporting, which is really this emerging area of interest. And we've also, heard from several land trusts who are using these products to talk about, the work they do and the importance of it. The Map of Biodiversity Importance is built on a whole bunch of habitat models. So what we've also seen is that those individual species models have also, proved to be very useful. So one of the ways those individual models are being used is to understand the stewardship responsibility of different landowners. The MoBI analysis took those models and intersected them with protected areas. We've done similar things with intersecting that information with, information on what land is managed by the Fish and Wildlife Service versus the BLM versus the Forest Service versus is private. So for each species, we can see that mix. Is this something that's primarily on Bureau of Land Management land? That might need a different conservation strategy than something that's primarily on private land. We have worked with the Fish and Wildlife Service to use some of these models to refine the range maps that the service uses for regulatory purposes. The habitat models, NatureServe habitat models, have been used by Fish and Wildlife Service also in figuring out what species should be listed as endangered. We've worked with several states to provide the information for integration into state wildlife action plans, and also just to support, the programs in our network with things like inventory. We're working with the Forest Service to get the models used for streamlining of NEPA processes. And we also are starting to provide the individual models to the public through NatureServe's biodiversity reporting tool, NatureServe Explorer Pro. One of the really important things, though, with all those examples that I do want to emphasize a bit is that this is a regional conservation planning exercise. The Map of Biodiversity Importance is built using this great data collected from our network, but it's based on models, right? This map is not telling us we know for certain that these species are there. And it's really focused on those things that are globally imperiled. And as I mentioned before, there may be a lot more of conservation interest within a particular state. So one of the more powerful messages I want to try to communicate today is that the Map of Biodiversity Importance is really best used in tandem with local knowledge on what's going on the ground. This example here, this is the Florida Natural Areas Inventory. You can look at the Map of Biodiversity Importance, see the Lake Wales Ridge popping out as an area of particular importance. But if you're considering a parcel on the ground, you really want to know what's going on there. And a lot of the programs in our network have their own tools, sometimes tools that are supported by NatureServe's technology backbone, to answer that question, to provide you that really detailed place-based knowledge on what's going on. What you're looking at on the screen is just a little report you can pull up from the Florida Natural Areas Inventory website, their biodiversity matrix query tool. You can click on a grid cell and return back a list of the species that they have actually documented at that site. Similarly, the Pennsylvania Conservation Opportunity Tool is another one of those examples. One of the things that MoBI highlights is that aquatic biodiversity in Western Pennsylvania and places like the Allegheny River and French Creek. This provides a view of the global importance of those areas for fish and mussels. But what do you do next with that information? You can go use additional state-based resources like the Pennsylvania Conservation Opportunity Area tool to learn more about what's there, what's present, and what conservation actions could be taken to support those species. So there really is this wealth of resources at the state level. I know we had a number of people up and that's just another example of the types of reports you can get from that tool, information on species of conservation need that might go beyond those globally imperiled species in the NatureServe maps. One last example, this is from Missouri. I know we had a number of people from Missouri sign up for the webinar. It's also a place that popped out with the Ouachita Mountains in those regional maps. Missouri is one of the states that works with NatureServe to we provide them the kind of technology backbone for an environmental review tool that provides access to the data that their heritage program collects and manages. Here you can go in, register for the tool, select an area, and generate a report on what's occurring there and what kind of actions are appropriate. So really want to encourage people to look into those resources, and here's how to do it. So if you're interested in learning more about the Map of Biodiversity Importance, that code right there, if you want to screenshot it, that'll just bring us to our webpage about it, which links to a number of different things. And then there are a couple different ways to access the data itself, which I'll walk through quickly. On the web page, there's links to some story maps. There's that journal publication that goes into the deep science of what I've talked about. To access the actual data, Esri's Living Atlas provides many of these layers. What you're looking at here is just that species richness. You can do things like pull in conservation easement area, click on the map to learn a bit more. And then here's the information on, how many imperiled species are at this location based on the map of biodiversity importance. If you just want to explore these data, this is a great way to do it. Just go to the Living Atlas, type in map of biodiversity importance, look for the 2024 data, and you should be set to go. For those who are more GIS users, I want to point you to NatureServe's Open Data Hub. This resource has many of the different freely available data sets that we provide, but in particular, the layers in the map of biodiversity importance. You can search for the layers, pull them up, and if you go into the metadata, you can see how to actually download that data and pull it into your own GIS system. We're constantly adding and updating resources on the hub, so it's also where you can find kind of the latest and greatest of NatureServe data. And this is just showing that if you go in, you search for the map of biodiversity importance, again, look for 2024, you should be able to get the full range of layers, species richness, range size rarity, protection weighted range size rarity for all species, but also broken down for species groups like pollinators, invertebrates, and freshwater invertebrates. One of the other really great things about the hub is that it has this map. This is an interactive map where you can click on a state and get that connection to those local resources I was talking about. So for all the state programs in NatureServe's network, we have a link to the program website. And for most of the states that have a specific data access website, we have a link in this tool to that as well. It's a really easy way to start exploring what might be available from your local programs to do that drilling down into that local knowledge. And really just want to acknowledge that this MoBI would not be possible without all these programs. These are the breadth of programs in our network, but also there's just a lot of other great resources that can support local conservation planning available from each of those. And finally, I just wanted to call out that I spoke a little bit before about the individual models that feed the map of biodiversity importance, focused today on that aggregated map. But if you are interested in learning more about those individual models, we at NatureServe is hosting a webinar coming up in November, where we'll be sharing a new dashboard we've built that provides information on the models we have available, as well as information on how those can be accessed through tools like NatureServe Explorer Pro. So if one webinar isn't enough for you, we'd be glad to have you back for another. And with that, I want to thank you all for your time. If you're interested in staying connected with NatureServe, here's a couple different ways to do so. And I would be happy to turn it over to questions at this point. And here's contact information as well for both me and Chris, if you have any questions.
Well, thank you so much, Regan. That was definitely packed with information, and I know that Chris has been, it's a good thing his fingers are okay, because he has been busily typing answers to many, many questions. So you are free if you need to add a couple extra questions. I think some of them you answered as you wrapped up along the way. So if I ask a question, maybe we just are referring back to another place in the presentation. So the first one is specifically about California, though my sense is the overall question could apply to any state. The biodiversity map shows California with a lot of at-risk biodiversity. And I realize that this is due in part to the high biodiversity in the state. At the same time, California has more habitat conservation plans that are designed to protect species. Can you comment on the value and effectiveness of HCP programs and your thoughts on the California 30 by 30 program?
All right, so I am going to be a little disappointing in my answer because I can't really comment on the effectiveness of those. I will say our map, one of the tricky things about the MoBI map is it's showing areas that are important for at-risk species, but that isn't necessarily a correlation with areas that are not well managed. You know, there are biogeographical trends that drive a lot of those patterns. There's also land use change, you know, land use, the kind of threats that drive those patterns, but I don't think it's fair to look at the map and say because it's red, it's an area that's not being well managed, or it's definitely an area worthy of attention. I just don't feel like I'm knowledgeable enough about habitat conservation plans in California and specific 30 by 30 priorities. So I'm gonna skirt around the edges of that. But the
No problem.
heritage program might be a good place to start as well.
No problem. And the one thing I do want to say is we are getting close to the top of the hour. Regan has and Chris have generously agreed to stay on beyond the top of the hour. So even if your question does not get answered while you're here, if you have to drop off, please know that we will continue to answer questions and we will stay on until we get through them all. And then those will all be included in the recording. So next question, if we wanted to utilize some of the resources to analyze more localized data or run similar models, do you have a list of recommended resources we could use?
Yes. So I think the question about modeling, there's probably a lot we could say there. So the global NatureServe has been focused on developing range-wide models for all these species, but often, you know, doing a local model can get you additional nuance, might be locally more accurate. There are many programs in NatureServe's network that are also producing models and might have good local models. We've developed a lot of resources about modeling that also could be a resource. So for example, we have a habitat modeling standard that we developed together with our network on kind of guidelines for how to approach this well. And there's a link to, if you Google NatureServe habitat modeling standard, you'll likely find it. I think one thing I would caution people about is the models really are as good as the inputs, right? So we've played around a bit with, say, pulling GBIF data and creating a model versus pulling the data from the local heritage program. And generally that, you know, more vetted data, things that aren't as, sometimes with things like eBird, you get weird kinds of biases as well in where data are collected. All that should be considered. So there are nuances to consider. It's maybe worthy of a longer conversation, but there's a lot of lessons learned that we'd be happy to share.
Okay. What constitutes protected land? Do certain management activities need to be implemented, or do conservation easements count? How are you quantifying that?
Yeah, so we quantified it based on the PAD US, so the US Protected Areas database that USGS puts out, and we considered anything that had a designation of GAP status 1 or 2, which has in the definition that it's managed for biodiversity. That does not include multiple use like Forest Service and BLM lands. There was a lot of discussion and debate about that. We've actually run some things both ways, but that getting a good protected areas representation is a real challenge. And that's one of the reasons we have both versions, kind of the protection weighted and not protection weighted. It's certainly, right, like to create this national product, we sort of had to go with best available, readily available, and that's what we used. But I definitely think it's important to recognize that's what it means. It's just those kind of wilderness areas within national forests, for example, and any conservation easements that are in that data set with that designation, but certainly not everything that's out there.
Okay. There seems to be a lot of overlap between this map and the maps that TNC and partners have made for climate change, resilience, et cetera. This is more of a comment, but is this just something that it's because you're using that data?
Yeah, so don't totally quote me on this. So a lot of it is common patterns, right? If you have intact areas, you may have more biodiversity and you may have more climate change resilience. There my understanding is that the TNC terrestrial resilience layers, at least, incorporated NatureServe network data at some point in the past. It's been a while since they've gotten updated data for us, so I suspect it's a little bit out of date, but that there is some feedback there. One of the things that we've been really looking at is kind of what are some different ways that you can combine these various data sets. They are answering different questions, but as you've said, there are also those areas of overlap, which I would argue are pretty important areas to be focusing conservation efforts on.
Okay. How does range size account for species life history? For example, large carnivores that might have a bigger range than, say, an endemic species of amphibian, but which also have individually much larger territories, or species that migrate and may have a large total range, but a limited range on one end of their migration. Did you follow?
Yeah. And the range size thing is really complicated. And I think it's a bit of a simplification, right? Like we can say small range species have fewer conservation opportunities, thus where they occur is more important. That is a simplification, right? You could have robust populations for, a plant within a small area, and that would never be able to support a large carnivore. Their kind of range size needs are greater. So I do want to be upfront that it's a simplification, and it's one we used. One of the things that MoBI does not really account well for is some of those more wide-ranging species, or even things like grizzly bears that may be of conservation value but aren't listed at the full species level. They don't even make it into the map. And if they made it into the map, they would make it in with a very large range size that downweights them. So that is important to understand. Like the MoBI products are pretty focused on where do you have the things that are the rarest of the rare. And depending on your applications, you might want to be pulling things in like connectivity areas or the ranges of particular species. The second part of that about the migration. So Chris might need to pipe in the chat because I may get this wrong, but I believe for birds, at least, we concentrated, like we mapped the breeding ranges and included that in MoBI, but did not do all. I'm going to let Chris answer that in the chat because I'm going to get it wrong. But there was some thought given to migratory needs. But again, it's hard to. This kind of product doesn't quite meet that threshold for capturing everything that's important for every species, which is part of, the discussion about how you can connect with those local resources, which often will be mapping out, this is a particularly important area for migratory population or whatever's happening on the ground.
Gotcha. Can we examine a grid cell to see what data contribute to its values and get some understanding of the basis for the score? Is that a possibility?
Yes. So I'm trying to share my screen again. Sure. So that one graphic I had that kind of showed the stack is our sort of the best thing we have for illustrating that. One of the challenges with NatureServe data in general and the Map of Biodiversity Importance is there's a lot of sensitivity about revealing the precise locations of many of these species. So we would kind of love to release a product with this that allows you to drill into a spot and see exactly everything that contributes to it. We're basically not able to do that. Our network of data providers isn't comfortable with us providing that. We can share the slide deck, which at least has that one illustration from Texas, and also happy to follow up with some more specific examples.
Are the U.S. species using this new data version for decisions in land use BLM and ESA in justifications and court challenges? That's an interesting question.
To my knowledge, no. So what we are doing is working with a lot of the federal agencies to provide them the individual habitat models. The Forest Service is probably the agency that's doing the most with that right now in terms of figuring out how they might use those for regulatory uses. Fish and Wildlife Service, in some cases, they've been part of the body of evidence that's used in decisions about what should be listed. BLM is using a lot of the models to figure out what species should be on their special status list. So understanding, like, is this a species that's highly imperiled and occurs mostly on BLM lands? They're using that information to prioritize what species and potentially where they're doing actions. But to my knowledge, not to the level where it's been used in kind of high stakes regulatory decisions.
Okay. So I have someone who's asking questions about the difference between the gray and the light pink on MoBI, and then came back and said later, do the gray areas on the map mean they don't have a score, or that their score is too low to be considered important or imperiled? Is pink better than gray?
Pink is bad, so I need to look at a map.
Okay.
So yes, but so because this is just the most imperiled species, yeah. The gray areas are where we do not have a map distribution of an at-risk species. So there, it doesn't mean there's nothing there of, no biodiversity importance, because of course there's things that aren't critically imperiled or imperiled that are still of biodiversity importance. But it means that there is no species in our list. There's no species in our species list that occurs in that area. Where the pink are lower scoring areas. So there's something there. Often, especially in the East, those are kind of wide ranging bats that have a low range size rarity score, but are predicted to be in that area. So yeah, the gray is kind of a 0 value and the pink is a low value.
Great. Well, down to our last two questions. I see Chris is answering the third. So someone commented that this reminds them of Map of Life, the Map of Life project. Is there any collaboration between NatureServe's approach and theirs?
So we've talked we've actually provided some data to Map of Life. They're working at broader scales than we are. So I think that's the biggest difference, is just kind of the resolution and kind of inputs that are going into that. It's a little bit more focused on those global patterns. We're still working at national regional levels, but honing in a little more. And we're also a lot more focused on those imperiled species than trying to represent everything.
Okay. And then the last question is, and I probably can sense the answer, but do you ever take a position or monitor local initiatives that have potentially severe impacts on imperiled species?
Yeah, so that's an interesting one. So NatureServe is a bit different than a lot of conservation nonprofits in that we are completely non-advocacy. So our mission is to provide information in service of conservation, but we generally avoid taking a stance. We're just trying to get good information out in the world so that it can be used appropriately.
Great. Well, thank you so much. That was a lot. A lot of great questions, a lot of great information. Just a reminder, the recording will be sent to everyone who was registered for this program, as well as a PDF of the slide deck. So if you missed the QR codes, they will be included in that resource. Regan, thank you so much for your presentation today. We really appreciate you stepping in to help us out, help Chris out, and to share this information. And Chris, thank you for all the behind the scenes work. He has been, you don't even know how many questions you would have had to answer if Chris hadn't been here. So thank you, Chris. All right, so I hope that you will all join us on October 29th for our next webinar. And Esri is partnering with some work that's being done by NASA. So take a look at our website and you can learn more about that. So thank you everybody for being with us today. Thank you again, Regan. Thank you again, Chris and NatureServe for all this wonderful work. And we'll see you again soon. Thanks.
Thanks so much for having us.